Hello everybody, I'm Nick, and this is the second part in the series all about cracking the .NET interview, where we're talking about the API integration test. And as a refresher, the API integration test is when the employer, when we're interviewing, gives us an API and say, okay, integrate with that API and expose that data in a very specific way. And we did that implementation in the first video of these two-part series. So if you want to check that out first as a refresher, please do that. You'll find the link at the top right corner of your screen right now and the description. But in this second part, we're going to talk about the testing, and more specifically unit testing and acceptance testing. I'm going to go through unit testing because we've done it a few times. So I'm going to briefly show you the cases, and then I'm going to move into the acceptance testing, which is a bit newer maybe for you as well, where we are testing our system in a way that the user would actually use our system and get a realistic view and test around that. It's sort of end-to-end, but in some cases not really. We're going to talk about this in a second a bit more. But being conscious of time, I won't be implementing it from scratch in this video. I actually have a second video coming all about acceptance testing and how you can do it with Specflow. So here I'm just going to talk you through the code and explain why I'm doing what. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell to get alerted when I upload a new video. So let's go straight into the code. And what do we have here? Well, if I go to the terminal, I can do .NET run --o e2. E2 is an out code. And by calling that, I am going to call that external API, map the data, and then return it in a specific way. And in that scenario, we're returning the name, the rating, and cuisine types. That's what it was asked from us to do in the beginning. So we have a fully functional system and we want to write tests around it. And why do we? Well, first, it is mandatory from the test, but even if it wasn't, you should be writing unit tests. And in fact, because we're talking about acceptance criteria as well, we're also going to write acceptance tests. So first, let's start with the unit testing. Let me close that. And I'm going to create a new project. And I'm going to name this API integration test, which is the name of the main project, .cli .tests.unit. And that's going to be the name of my unit testing project. And I'm going to delete that class. We don't really need it. I'm going to add, I think, 3 packages. So first, we need any substitute. So this needs to go in first, and I'm using that for mocking. I have a video on it if you want to check it out individually. And then auto fixture, so I'm going to add that as well. Yep, here we go. And last but certainly not least, we have fluent assertions actually to help assert in a more elegant, more human readable way, and get also better messages when something goes wrong. So with these 3 packages out of the way, I'm going to create the first class. And the way I like to create my classes is I take the class of a thing that I want to test and I stick a tests at the end, and then I'm testing the methods that I want to test. So there's 2 things I'm going to be testing here. The first one is the restaurant search application, which, if you remember from the first video, is sort of like the entry point that if we go to program.cs, we're going to be calling to start the journey, the request journey. And I'm also going to be individually testing the restaurant search service, which is what's calling that external API. And we're going to have to mock that. So those are the 2 things I'm going to test. I'm going to use a real implementation of the validator, mainly because the validator isn't actually doing much and it's all in memory. And we want a realistic representation of that. Could I mock it and write a different testing class? Yes, but in scenarios like this, I prefer to go about it this way, killing 2 birds with 1 stone. I know some people don't like that, so if you don't want to do that, that's totally fine. You can choose to go whichever way you want with that. So with that out of the way, first let's go ahead and test the restaurant search service. So I'm going to copy that name and I'm going to say class restaurant search service tests. And the first thing I do is I create the system under test. So private read only the name of the thing I'm testing. And I'm just going to refer to the project. And I'm naming it SUT, or system under test. And then I'm initializing that SUT. But before I do that, I need a mock. So private read only restaurant API. And I'm going to mock that. So I'm going to say restaurant API substitute.for, and I have the interface name here, so that goes there. Here's our mock, and then I'm going to actually create the real validator. So validator for what is the request I'm validating for? Here we go. So iValidator for that is validator. You should be injected here. Co equals new validator. So we have all the things we need to create the system on the test. So I'm gonna say SUT equals new that service. First goes the mock, and then if I can actually find the button, the validator. Here we go. And now that we have that, we can actually start writing our tests. So what do I want to test at this point, right? I want to test that when I'm using an out code, the request is returning actual results that are being mapped properly and returned as a restaurant search result. So I'm gonna have to mock this method here. And the other thing I want is when I'm not providing a valid out code, the validator is kicking in and I'm getting a failed state. So let's go with the happy path first. And the way I like doing this is I'm copying the name of the method I'm testing. So I'm gonna create a fact, not a fact here. Yep, here we go. Here you go, public async task for the test, and then name of the method underscore, and what should this do? So should return results when out code is valid. Here we go. And then here's where I'm going to create my AAA, my arrange act assert, and I'm going to implement that method. So let's see what our act should be, right? So we have a result equals SUT dot, and it's the only method, and that should be awaited. And to arrange, we have a restaurant search request. So if I copy that, var request equals that, and then we need a const string, which is the out code. So out code equals E2, and I'm using E2 because it's mentioned in the actual README file as well. And you go here and then request, and then the assertion should be that the result is matching the mapped version of what the API is returning. So we're gonna have to actually mock this call here. And the way to do that is I'm gonna say restaurant API dot search by postcode, and I'm gonna use the out code here. Returns, that's how an substitute works, and then we need a response, so var API response, and that's where I'm gonna actually kick auto fixture in. So I'm gonna say private read only ifixture underscore equals new fixture. Here we go, and I'm going to use that to create the response of the API because we only care about the mapping here. So I'm gonna say create, and the thing that API returns, if I am not wrong, is create that here. And then what we want is the expected result, and that would be a new restaurant search result. Here we go. So now we have that, I can say restaurants equals, and then I have the API response dot restaurants dot select dot to restaurant result, which is the mapper dot to list, and we can say the API response should be returned here, expected result here, and then all I need to do is say result dot as t0. We're using one of here, so I'm gonna get the first parameter of one of should be equivalent to, and we have the expected result here. And just because I'm using records, I actually have to add an extra thing because the thing will fail, but the Fluent session team is actually working on it already. I'm gonna say comparing by members for the outer class, so the result, and then also comparing by members for the restaurant result here. So if I open the unit test window, or actually if I just say run this, my unit test is passing. And if I was to actually debug it just to show you what actually happens here, we are initializing this. I shouldn't have stepped in there. We are creating the fixture, and if you see, the fixture actually has 3 restaurant responses in it with a bunch of items in them, so plenty of data to map. We're mapping the expected result, and then we're going to the system under test. The postcode is validated, and then the API is returning the fake response, the mock response that we want. It's being mapped, and then we are asserting here. So this is all great, and we have the first unit test. Now The other thing we want to test is about the postcode being invalid. So I'm going to copy that. And it's not a postcode, it's an outcode. So should return error when outcode is invalid. That's great. And if I say like 1AA, just a wrong outcode, I don't even need to mock the API response because there won't be an API response to mock. But what there will be is a new restaurant sets error, sorry. There we go. And it's going to have some error messages, I think. So error messages go here equals new array of strings. Do I even need that? I can just say this. Too many S's. And I think this goes here. Yeah, here we go. And the error we want to have in there is this. Please provide a valid UK postcode or outcode. So this goes here. And what we want to do is say as T1, which is the bad response in one of, as T1 should be equivalent to, and we have, can I just get the error messages? Actually, I can just do this. And I need the same exclusion. So options equals options dot compare by members, and it is the here we go. So if I am to run this, it might fail. Oh, it succeeded. So if I run both of them, so both my tests are passing, they both are returning an error. Let me quickly debug this as well, just to see exactly what's going on there. So yep, we're getting the errors back. The T0, which is the good result, is not populated. The T1 is. Again, if you're not familiar with OneOf, I have a video all about OneOf, which you can check. I like using it in general in scenarios like this, where you want to return one of two things or one of three things. So the error is there coming from the validator, and this is all good. Now, the other thing I want to test with that out of the way is the high level, the application. And in that scenario, we want to check that we can write to the console and that whatever we write in the console is correct. So I'm going to follow the same approach. I'm going to create this class again, tests, and I'm going to write the two unit tests I want to run, which is good results and bad results. Now, I'm not going to actually show myself writing them. I'm just going to implement them and talk you through them. They are conscious of time because I want to focus on the acceptance testing a bit more as part of this video. So here are tests for that other class, and let me talk you through them. So the method we want to test is the run async, where we get the arguments from the command line and we go through the actual application flow. And things like the restaurant search service, which is what we just test, are now mocked because we don't care about that. All we care about is, are we writing to the console, and is the user seeing exactly what we want them to? So that's what we're testing for here. And we have our arguments in an array, as you can see, in a very similar fashion, and we have the test saying run async should return restaurants when outcode is valid. And now you can see why I used an iConsole writer as part of those tests, because it allows me to mock them, and then I can validate on the calls that mock received. And we have, again, that other service also mocked because we don't care about any API calls. All we care about is, can we write correctly to the console? So for that, we are creating a fixture of the result that we want, and we create the request in a very similar fashion, and we're sending that down the search by outcode async method, and then we're serializing the result. We are intending it properly, and then we're checking that the console writer received exactly one, as you can see here, call with the argument that is matching the text that we expected it to match. And similarly, we are checking that the postcode here, let me just make it a bit bigger so my face doesn't cover it. We're checking that if the outcode is incorrect, we're checking that validation is kicking in and you get the appropriate error message. So this is all the unit testing we need. So if I select to cover those, as you can see, 2 and 2, 4, and if I go to code coverage, I can exclude the test code, and I can exclude the proxy that I'm using. So 72% of the application is covered. What isn't covered is the program, the actual program, and then the output, which that's fine. You can test it if you want independently, but there's no value really in it. However, This obviously doesn't fully cover the application. It doesn't mean you should fully cover every application you build for an interview test, but it's good if you do that. But here is when the acceptance criteria kick in. Because we were instructed based on specific acceptance criteria, it's a good idea to try to create acceptance tests for that test. And here's where it gets interesting, because you might know how to write acceptance tests for like an API, right? You just call the API and you expect that the results are back and you write your gherkin, and that is fine. But what happens when you have a CLI application, right? You need to actually pretend that you're a user typing into the console and you see the results you want to. So this is where it becomes a lot more interesting to me. And to spare you the tedious implementation, I've actually done this off screen and I'm going to talk you through the project. But here's what the acceptance testing is looking like. And this project doesn't have any dependencies. I could take this, put it somewhere else, and it will still work the exact same way. I'm not using anything from the main project. It treats the system as a agnostic thing that you're just calling and you're validating against. And if I go to the feature classes, which we've talked about Specflow before, I'm using Specflow for this, you can see what my tests look like. So I have two scenarios, and I have one feature. The feature is a specific feature of your application, basically. And I'm saying that search for restaurants by outcode, that's the feature. And as a user, I want to search for restaurants that deliver at a given outcode. And then we have two scenarios. The first one is restaurants that deliver at an outcode. And then given an outcode E2 and the following restaurants are delivering there, when a user searches for restaurants of the outcode, then restaurants are returned. And then we have the invalid, where you get the error code back if you provide a bad outcode. Now, something interesting about writing acceptance tests for those external APIs is that you don't actually control them. And for example, I could try to write acceptance tests, but since I don't control ordering and whether a store will come first, second, or whether a store will change in rating and go higher or lower, I cannot run them in a deterministic way, basically. Now, the way to get around that is to introduce something called wiremock. And this scenario, it's called wiremock.net, actually. And I'm actually going to make a video about that. Don't worry. I'm going to explain you exactly what it is. But effectively, it allows us to create a local API behaving like the one that we want to call. And then it's a matter of redirecting your application to talk to that API instead of the live one. And I'm going to show you how I did that in this example. But I'm able to actually create an API, tell it exactly what to return, so I can write my tests, and then as part of the test, spin it up and tear it down. So completely isolated. And you could even wrap it around Docker if you wanted to and have the whole thing in Docker. For that to happen, however, I need to actually change one thing in the main application. I need to go to the program.cs where I defined my configuration, and that is here. And I'm going to have to add a new package, and I'm going to say environment variables. So I'm going to need the package microsoft.extensions.configuration.environment variables. I'm going to add that, and I'm going to say something like add environment variables CLI underscore. And what this will do is it will be able to pick up any configuration that lies as an environment variable in the system. And then I can have something like this, and let me just copy that, where I have this and then double underscore, which means it's a child object, this. And then if I set this environment variable to something different, let's say whatever the wiremock address is, like this, then the application will start pointing on that automatically. It might be a bit confusing, but on the dedicated video, I'm actually going to talk about it more. But now that we have this, we can go to the feature, and we can go to actually to the hooks. And the Specflow hook is a type of binding where you can specify something like before scenario or something like after scenario. So what do we want to happen before a scenario? We want to locate where the project we're testing is. We want to build it or publish it, depending on what you're doing. And we want to run it as if we were a user. And then we want to make sure that all those features can actually run. So let me go to the steps, and for those of you not familiar, each line here is a step in Specflow. And for example, this step here that actually has a table under it, if I F12, you can see how that works. It has it's a method with a given attribute, and then it takes that input as a table, it's converting it into a specific type of object, and then it is mocking it in wire mock. So here's where we're using an object container that the system supports to take it and say, given a specific path, in our scenario, the path that we need to mock or to make the API return, respond with this code. And this wire mock thing isn't like an in-memory mock thing. It's an actual API running on your machine. So you would actually call it from your browser. Don't think that this is like a purely mocking thing. It's an actual API, and a call will fire over the wire to that API. And then you just serializing the response, or you could even load that response from a JSON file, and you can do all sorts of things. WireMock is amazing. I'm going to talk more about it in a dedicated video, but this is, for example, how I am loading the overridden restaurant API. The best way to actually show you this is to put breakpoints here, because I might be confusing you, and show you the whole lifetime of this test, and then go to the hooks as well, before scenario and after scenario. So the lifetime goes as like this. For each scenario executed, the before scenario will spin up, and then each step will go through. We're gonna validate at the last then, and then we're gonna tear the server down to turn it down. So if I now go here and I rebuild the project, and I find the acceptance tests. Oh, and I cannot do this because the API is running. So let me just stop it. I don't need it to run for the acceptance testing. I can go here and build it again. Here we go. And if I say restaurants that deliver at an outcode and I debug it, let's see what we get. So first things first, before scenario. So before you execute this piece of test functionality, go into this method and set up all the paths needed for this execution. So we're doing some path traversing here. You don't need to know much about it. And then we're gonna build the project. The project that we're gonna build is this project over here. And the way we're gonna do this is we're actually going to run a .NET build on that path. And we're gonna make a process, start it, wait for it to finish. And then once it's finished, we know the project has been built. And then we're gonna start the WireMock project. And then now that I have the started WireMock server, which I can actually call now if I want from my browser, I'm gonna put it into the object container, and I'm also gonna put the paths as well because we're gonna need them later in the steps. And now first we go from the first given, which is like given the outcode, and the outcode here is E2, so we're storing that locally. And then we go to the next step, which has the table, and we say the following restaurants that are delivering there. So we're taking them from the table, we are storing them locally, we're translating it into the response object, so we can configure WireMock to return it, and we're gonna get WireMock from the object container, and we're gonna configure it to return for that given outcode the specific response. And then when a user searches for a restaurant at that outcode, so the search looks like this, you get the WireMock server and the project paths. We have the argument, so the argument very similar to how we do it here. You do .NET -o when you run it, or .NET run actually. And we're passing this as environment variables. So we create the process, we start it. So the process now it's starting, and then the restaurants are returned. So we have to validate and assert that this worked. So the way we do that is we are taking the expected result from the restaurants we have set up in the previous step, and we make a result out of it. And then we read the result from the console as text. And this is actually, if I go here, the real output from the real CLI that is executed as a background process as part of this testing. And now this is done. And then we serialize it, and we are also making sure that they're equivalent. So these two are matching. And once we do that, we stop the server and everything is disposed and everybody is happy. And we have that test passing. I totally understand that this might be confusing. If you need to take a look at this code, by becoming a Patreon, you can get access to it and see exactly how it works. It's a very similar process to how you would do an API using Specflow on the acceptance test level, but I find the CLI particularly interesting because you have to deal with the process in a different way. So now that I have both of them here and I have all of them, I can simply go here and say cover selected unit tests. And once I do that, my unit tests will run, my acceptance tests will run, and I don't have the API running, so this is all happening automatically in my PC. You could always, if you wanted, Dockerize this as well. I would highly recommend it. I just don't want to spend more time on this. And now with all of them covered and all of them passing, the coverage is 100%, and we're testing both scenarios that the interviewer wanted us to address. So everything is there. We don't have to worry about it. This would be an absolute pass if you were applying for that. And again, if you find it a bit confusing or too confusing, you can take a look at the code by becoming a Patreon and taking a look at how everything is wired together. There is a video dedicated to that sort of acceptance testing coming soon, and also a dedicated video on wiremock. So I have so much I want to show you. It's just that I don't want to make this video 2 hours long talking about just Specflow. It's about the test, and the test is a pass. That's all I had for you for this video. Thank you very much for watching. Special thanks to my patrons for making these videos possible. If you want to support them as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.